All right, now we're going to talk about how we compare to numerical variables. So what do I mean by that? This is where I'm taking two measurements of the same participant. So let's imagine we're taking down someone's weight and their shoe size. And those come from the same person. We use scatter plots to show how variables are, or in some cases are not, connected. So here's a scatter plot. So let's talk about what each of these data points means. This data point, which seems to have an x value of, let's call it 95. And that looks like it has a y value of about 88. This represents one student. We're looking at reading scores versus math scores. So this is a student that this was their math score out of 100, and this was their reading score. Now it's important that for a scatter plot, the two numbers that are paired together represent the same person. I mean, it doesn't make sense to try to make a conclusion based on Susan's math score and Jose's reading score. It doesn't make sense to put those together. So these scatter points each represent one subject, one person. And our goal is to show a correlation. Now, what's a correlation? This means as one number changes in some way, the other number changes in a predictable way. So we often see that by plotting trend lines. So here we've plotted a trend line through this reading and math data. Since this trend line has a positive slope, we call this positive correlation. This means as math scores increase, reading scores generally increase. Now, there are exceptions to this rule. For example, here's a student with a lower math score but a higher reading score. And over here, this student has a higher math score but a lower reading score. The line between these two dots is not uphill, but generally we have an increasing trend. So trend lines are about generalities, not what happens between two individual points. Now, sometimes there's no correlation, or there doesn't seem to be much pattern. A good way to identify that is if you draw a circle around the data, as close to the data as you can. It tends to look like a big fat zero. So there doesn't seem to be a lot of connection between the diphtheria cases that a country has versus the life expectancy of people in their country. That's where I pulled this data from. It's from 2015 World Health data. This scatter plot shows what we call a negative correlation, because as life expectancy increases, adult mortality, which is the predicted number of people out of a group of 1,000, people who are between 15 and 60 who will die in a given year, or who are expected to die. So as life expectancy increases, adult mortality decreases. Now, we're not saying one causes the other. We're just saying there's a relationship. They seem to have this relationship. We don't know why. So just because there's a relationship, that does not mean there's a cause. Or, as the old statistics phrase goes, correlation is not causation. So, and we can see that these are decently correlated because when I draw a circle around it, it looks skinnier. It looks a bit like a 1. And the smaller the circle is, the stronger the correlation. So we'd say a tighter loop means stronger correlation in whatever direction we're going.